Hello. It's glad to be back at Bristech. This is my third Bristech talk, I think, but awesome conference so far. I'm Adam Butler. I'm a web dev. Oh, that's the hide button. Okay. Pro. I'm Adam Butler. I work at this company. We're called SimpleWeb, and we're based just down by the SS Great Britain. They have a much bigger boat than me. A small plug before we start. We are hiring, so please do come and grab me at the after party a bit later. So this talk was originally called Building Your Own Tools. And I decided to rename it to Don't Repeat Yourself because this talk's a little bit about mitigating risk, working more efficiently, and building more reliable products. And I was thinking about the tools that we consume and today mostly allow you to customize them, bring in your own packages to extend their functionality and alike. And because of that, I thought Don't Repeat Yourself was a bit more of a suitable title. So this is what I came up with as the description of the talk, and I'm not going to read this all now. Instead, I'm just going to highlight some of the main points. So what it's really about is reducing risk, some practical examples of tools that I consume and build for myself, and hopefully you'll see that we kind of have some business problems and a few tools that can help you solve those. So the first part of this talk is about preventing emergencies, and what I mean by this is getting calls at 11 p.m. telling you the database is down, or conflicting features going into production and going to hell. And these emergencies can present themselves when we don't really understand our products fully, or they're not predictable. It can be down to human error, time constraints, or the hardest one to recover from is simply not having domain knowledge because the person who built something is away or not even working for you anymore. And this point is especially prevalent where in 2008 a company called CompData did a survey that said that the average software developer stays with their company for only 23 months. And all these issues can be overcome with well-written documentation, comprehensive unit tests, and implementing process, be it manual or automated. So let's look at these three things in a bit more depth. First, and more important than anything else, is documentation. Without this, code cannot be tested in hindsight and processes become uninformed. But writing documentation is hard. And when developers are in the zone, it isn't really the top of their priority to be writing documentation. And this leads to writing documentation after the fact, which isn't terribly efficient. And you normally have to kind of go back and review the code. And you could use Git to your advantage to solve this problem, and I'd agree with you, but I prefer to take a bit of a different approach. So we'll look at some tools that can help us write our documentation as we develop. So here we have code annotation in the yard format. This type of documentation is not only great for giving the product developers instructions on the methods and the classes that we're using, but it allows us to generate our code in this format. So we can export HTML or PDF or various other formats and have this public documentation with really good searching tools and linking related classes and methods. And just as evidence that this is both practical and scalable, this is exactly what the Ruby on Rails project use, except they use RDoc instead of Yard. Now, both of those examples that I've shown you have been based on Ruby, but there are various other tools depending on your flavor of language of flavor, I don't know. And there's also a few tools which are completely language agnostic. And the real beauty of documenting writing your documentation alongside your code is that you retain it in version control. So you can see all the context of the document changing alongside this method changing up here. And these tools are all good and well for documenting your code and making it very searchable, but what about contextual documentation? The type of documentation that isn't actually linked to methods or classes. For this, we need to make it as easy for people to contribute to as possible. And most developers that I've spoken to at least favor Markdown as a way of writing this type of documentation. It allows you to write documentation with hierarchy without concerning yourself too much with style or syntax sugar. And better yet, Markdown looks like this, kind of rendered on the right, but is perfectly readable in the editor, so you don't have to leave the environment that you're in. It's great for developers. And a tool called Jekyll that was talked about in the last talk is a really good way of bringing all these files together and building a site. And this is exactly what we do with the documentation for one of our products called Rusic. We have a collection of markdown files that combine down into this website. It makes it really convenient for us to look at as a website, but also to look at in our editor. And our documentation is not only open source, but in fact it's forked from the documentation from Basecamp, another local company. And when we were developing our documentation, we implemented some new processes in there and simplified a few things, and we're actually able to contribute that back to Basecamp, which is really nice. So I'm going to give you a quick demo of the docs to give you a little bit of insight into one of the tools that we built to help make API documentation a bit easier. So like that. So this is one of our API endpoints in Rusic, and we've got this API Explorer here. It's got a bunch of headers. This particular API endpoint doesn't take any parameters. And you've got the body for things that you're posting, the IDEA content, IDEA title, and resources. We've got a bucket ID here, which is actually injected into this URL up here. And if I've got an internet connection, which I'm not sure I do, cool, okay. I send that off, and it goes off to our API, and we get the response straight back in the browser. And none of this is mocked. This is all using our real API. Please don't steal my tokens. And it's a really good way for people to play around with it, work out how to do things, for us to be able to share examples with people, and it's super useful for us. And this is how we actually define those pages. So we used web components to build these out. So we've got an API Explorer web component here that has I have a laser. No, that's not a good one. We have a resource and a method and a bunch of headers, a bunch of parts and whatnot, and all the other changes are done in the browser and then get saved to local storage and all that. But we've got a really declarative way of writing these API endpoints, and that makes them really easy to maintain, and that means they get maintained more often. But it also allowed us to build out all of our API endpoints in an hour and test them. It's super easy, and this just compiles, or this at runtime just makes up the DOM tree from our web components. Next, let's talk about testing. Subtle little portal joke there. I don't know if anyone will get it, but so how many people here unit test their code? Good, excellent. What about TDD? Much fewer, actually. Surprisingly few. Okay. So a quick intro for anybody who doesn't do unit testing. This is an example of Fizzbuzz. I hope you can all see it. So Fizzbuzz is a game where you give it 1, 2, and if it's you give it kind of numbers which increment. And if you give it 3, it will return, or multiple of 3, it will return Fizz. A multiple of 5, it will return Buzz, and a multiple of both, it will return Fizzbuzz. So this is kind of the specs that you'd write out for it. So this is testing the actual test method, and the play method you expected to return an array. But what tests allow us to do beyond this is makes it really convenient for us to test things that we didn't expect. So it's really easy just to go in the browser, or when you're building a site, it's really easy just to say, oh, it's working as expected. But this allows you to say, what if I give it a string or an empty array? And we can test that really easily with unit tests. But something people often ask is, does unit testing your code pay off? So I wrote this bit down because I want to be very careful about what words I used here. So I crunched some numbers, and I chose to be quite pessimistic about this process as to not be accused of making the numbers work in the favor of unit testing. But to compare manual testing against unit testing as equals, there is one constant that I won't change, which is that sufficient manual testing should be done to keep it to the same standard of unit testing. So here we have, for every, on the manual testing side, for every hour of development, we're going to spend 10 minutes manually testing for every hour of development. except we're going to repeat that over time. So every subsequent hour of writing your application code, we're going to retest the bits that we've already done. Versus unit testing, 2 hours of bootstrapping, and for every hour we spend 45 minutes writing unit tests. I really hope people don't, but we're only going to have to do that once, and we can just run it for free. And that yields this result. So on the bottom we've got the hours spent actually developing the product versus the total hours spent. And based off this assumption, take it with a little pinch of salt, it would suggest that it pays off around the 35th hour. So your total time spent, if you're doing unit tests, is going to pay off over a longer project of 2 weeks, for example. So it's really beneficial. And what tools can help us with our testing? Of course, we've got all the kind of testing frameworks, like RSpec, but you're all probably familiar with these, and I'm not going to go into these too much. Instead, I'm going to talk about tools that can help you test better. So here we've got Guard with Guard RSpec, and Pry with Pry Rescue. So, like that. Cool. So I'm going to go into this Fizzbuzz project here and run Guard on it. Put that on the right. Too many screens. Okay. Sorry about this. Go over there, please. Okay. So we've got our Fizzbuzz class here. In this document, what we can do is we can save this, and it will instantly run the specs for this particular class. And you'll see it's failing now. So we can come up and we can see what errors we have, and we can make our changes straight into the editor, save it, and it will rerun. And we can see it live, and this is really kind of the bedrock of test-driven development, because as we're defining new tests and we're saving the file, it instantly runs our test suite, and it literally tells us what line to write next, which is awesome process. I'll cancel out of this and show you Pry. So we have a bug there, and it's not working, so I'm going to run rescue RSpec, which is going to run rescue Pry, and it's going to take us straight into where this error occurred. And we expected Fizz here, but we got Fizzbuzz. So we can do edit source. Oh, no, edit method, sorry. No. This is really hard to do this way around. No? There we go. And it opens up this file, and you can see that our terminal is now hanging. Now this is a really good way of debugging, because I often find myself, or pre-using Pry, that's hard to say, I found myself going into an interactive console, doing some debugging, and then exiting out, rerunning from scratch, and I lost all the context of my variables. Whereas this, as soon as you save the file, I'm not actually going to fix this now because it's a bit dull, and exit out of it, you'll see that our console comes back. We don't lose any of our context while we're debugging, and that it makes writing our specs and fixing our code extremely quick and awesome. Right. And writing unit tests, the main thing that's good about it is when you write your unit tests, you get a real sense of how good your code is. Easy to test code is usually good code. It's got separation of concerns. And it's a really good human measure to be able to test how well you're actually writing your stuff and doing TDD is even better of a measure because it actually defines your assumptions up front. Another little tool that I'm not going to demo now is called SimpleCov. This allows you to keep an eye on your test coverage and make sure that large parts of your system aren't being neglected. Really useful tool. Next is process, and process is kind of a talk within itself. For me, it can be measured by one metric, having the confidence to make assumptions. So we talked about deploying earlier. There was a talk about deploying earlier today. And we tend to ship one of our products like 6-7 times a day. And I could relatively confidently go onto one of our projects now, onto master branch, and just ship it and not worry. I wouldn't like go onto the server and check, and that's because we've got process in place and I can make the assumption that it's safe to ship. And when I started writing this section, I wanted to pick out some of the most valuable bits that we've adopted and developed for ourselves. So I've taken one thing from writing, one thing from reviewing, and one thing from shipping. So on the front of writing is code consistency. This is kind of the most important thing for me. It's so consistent. And I can tell you if developers ever divide and declare war on one another, it won't be the battle of languages. It certainly won't be procedural programming versus object-oriented programming. Hint. That's coming up. No, it will be around tabs versus spaces. Always. We can solve this problem pretty easily with something like editor config. So if I jump back to that project, if it'll let me exit. There we go. If I jump back to this project, you can see that I've got this editor config file here, which defines a bunch of rules for this project. Things like use spaces and 2 spaces for indent, trim white space, etc. And those are kind of rules that we'll see as we develop our code. And if I can't see anything up there. And if I go back into this function and, for example, add loads of spaces here and save it, you can see it's automatically removed. But the benefit about this is it allows you to kind of have your own code style, but enforces it at the point of saving. So if you had your Sublime text, for example, set to using tabs, then it will just convert it all for you at the point of saving. But we've also got linters. These can be really helpful as well. Enable linting. So in, do we have that in here? No, okay. I'm just using the default Rubocop linting here, and it's complaining about various things in this. We've got a string up here without interpolation, so it wants me to have that as a single character. We have a class without comment, raise instead of fail, etc. There's just loads of bits in there. But by using tools like this, we can implement a lot of consistency throughout our code base. It makes it a lot easier to read it, makes it a lot easier to make assumptions about where things are and how they work. Really useful tools. Cool. The next thing is reviewing your code. Now this one's really quite simple because we like to review all of our code changes in one place. Pull requests. They're just perfect the way they are. Is Andrew in the room? Is he? No, he's not a bastard. Now I'm sure most of you use pull requests and you're very familiar with them. There is kind of a point to this. It's about the process instead. So with pull requests we have a few rules that we follow at work. Open as early as possible. It provides the best place for everybody to have visibility on what's going on, what's in progress, and you just put a flag against it, work in progress at the start, and all the visibility is there. And even if a bit of work's been frozen, then everyone knows about it, and there's no duplication of work. Use descriptive titles and body. So pull requests provide the best piece of documentation for a feature going into production. And this often gets overlooked because normally you're sending it to somebody who has the context. They know what you're doing and why you're doing it. But you should always, despite this, write good descriptions in your pull requests. It's the most useful tool when looking back. Keep the conversation in line. So this is things like, can you look at this code? Don't put that up in the description, put it in a comment. This keeps it contextually aware where it falls in with commits and things like that. If anyone puts in the description, I don't know whether they've committed since they asked me to look at it. So I'll usually ignore it. This one's used by probably everyone here. Sender, please look at this when you're ready for it to be reviewed. This usually goes to, in our company, it goes to the most relevant person, whether they're working on the project or not. So if it's a Ruby project, I got 4 or 5 people who might not be on this project, but it will be sent to them anyway. And everybody merges and ships their own work. The main thing for this is it's really good for team motivation. It gets everybody used to shipping and deploying and things like that. But most of all, team motivation, it's really nice to ship stuff, especially on a Friday at 5 to 5. And talking about shipping, what we got? So with a few of our projects, we might be shipping into production several times a day, maybe a dozen times a day. So we have a few processes that help us do this. So we always deploy to staging before we go into production, and we replicate our production into staging environment regularly, and hope on some projects automate that. We have SHA pages. This is a really quick and easy way just to sanity check things. So if you go to one of our products, rusic.com/SHA, it will give you a little short SHA of the last commit that's been deployed. Super useful. Master always reflects production. Like I said before, I'd be quite happy to go to any one of my projects, don't hold me to this, and just deploy it now without knowing what's on it, because of the processes that we have in place. Good rollback plans, Capuchano can help you with this. So when stuff does go wrong, we can easily pull it back and work out what's gone wrong. And bringing you on to what's gone wrong, release monitoring. So every time we deploy something, we inform Bugsnag or Semaphore or whoever we're using. We let them know something's been deployed, we give them the commit, and that way, when issues do occur, or in this case, 46,211 issues occur, we know about it very quickly and we can fix it, and we know when it was introduced. Not as bad as it seems, I promise. And ideally, I put this in brackets because we don't actually do this. I'd love to actually do this, but we have so many projects that it would be a bit of a pain. Hubot integration. This is what GitHub do. So you deploy straight from Hubot. The whole company knows it, knows that you're shipping, and then you get a response back saying it's available here. That would make our process really awesome. Oh, I have a screenshot. There we go. That's it. So, that's end of part 1. Part 2 is about tools. Now, this GIF really has nothing to do with my talk. I couldn't find a GIF, and I think this is the most awesome GIF that I know. So I thought, fuck it. I mean, you know. So the tools that we have today allow us as individuals to do what would have taken teams to do 10 years ago. And it frees teams up to innovate on a scale that's just never been possible. And by automating repetitive tasks, we're able to reduce risk and focus on what's really important. And we have a thriving open source community. GitHub, they recently announced that they've got over 11 million users contributing to 27 million open source repositories. It's just a huge amount. And most of the tools that we use in our projects nowadays are open source. In fact, from just the bits that I've shown today, all of these are open source. And it's really easy to take it for granted. Of course, we still have established closed source tools. Both of these tools are very extensible. GitHub for its integration and APIs, and Sublime through packages. Something that we didn't have in the days of Dreamweaver and Notepad. But despite their popularity, we're starting to see some traction from open source alternatives to these tools also. Now, this is Okay, I should have used this for the tools, because this guy built a Wolverine flamethrower thing, which is perhaps the best tool ever. I'm not sure it's useful, but it's awesome. This is the part of the talk where I get a little bit self-indulgent, to get to the heart of what this talk was about. Don't repeat yourself. If I find myself doing something twice, it's pretty typical of me to automate it. So here are some tools that I've built to solve some problems that I faced, and hopefully some of you will find them useful too. So the bedrock of this is my doc files. I put most things that I want to just be able to do something very specific very quickly. I throw them as a function or an alias or whatever in my doc files. So none of this works. Okay. So if I open up a new terminal tab here, so my base for this is I start off with another open source project, OMyZSH, to get this nice colored terminal. I've got kind of all my other colors on top of that. And I get loads of free stuff out of the box, things like being able to jump to projects, just jump to Rusic, for example. So it allows me to navigate very quickly. But a lot of this I've extended myself. So these are two files in my doc files, loads of aliases, even ones that fix my spelling mistakes, just so that it doesn't disrupt my flow when I type in the wrong things, as well as a load of functions for more specific things, like feature that checks out master, it pulls it down, it then checks out the branch that I define, commits an empty commit. This is what I was saying about putting your work in progress up. The easiest way to give people visibility of what you're working on is not to wait to a point where you're ready to share it with the world. I always do an empty commit and push that up, because it gets rid of that whole decision straight away. And then I push it straight up and open up a pull request for it. I've also got my language is just atrocious. Who the fuck is using port? Because I can't remember LSOF-ITCP:$. No, this just allows me to just see what ports are being used, and things like fixing permissions and directories. But one I'm particularly fond of, who here has to write timesheets? It's horrible, isn't it? Timesheet reminders are coming. In fact, we have automation inside our Slack channel reminding us. It's just a terrible thing. And I'm terrible at writing my timesheets. So I made a tool. What the fuck have I been working on, it's called. And what this essentially does is it goes into my sites directory, CDs into every single directory, does a git log against my username with a bunch of date stuff and things like that, pushes it into a file, and then sorts it by date, and then pipes it into less, and removes some UTC rubbish as well. So what I end up with is a view like this. I work much harder than this. I just had to remove everything that's sensitive. So there's big gaps. These are just open source projects. So I end up with all of my different projects, their directory, what I did, what commit it was, the SHA and everything, all aggregated and sorted by date, which means I can just go in here and go, oh yeah, I spent 7 hours on that, 5 hours on that, whatnot, and fill in timesheets really easily. So. Next thing, I got married earlier this year, and decided it would be nice to have something a bit more automated than a spreadsheet. So I built a website for our wedding. So it does more than kind of the usual things that you'd expect, like RSVPing and uploading photos. In fact, it also manages my costs for me. So as people RSVP, it aggregates it across all the costs. I know whether things are per group or per individual. And it just works out all my costs for me and allows me to manage it really easy. And when my wife wanted the site updating, I just gave her a login. She's like, we need taxi information. It's fine, go do it. And this was just a really useful tool for me, but I decided to open source this also. And open sourcing it actually made it a better product. It's little things like being unassuming that the couple getting married is straight, for example. You don't have bride and groom. And you end up with a more flexible, a better built tool because of it. And with this tool, there's just a YAML configuration file to give you something usable straight out of the box, obviously with my design. But you can upload your photo to the venue and things like that, fill in the banner and all that, and it just works. And for the JavaScript group that I run, I wanted a really quick way to get real-time votes on what topics people wanted to hear about. So I built Poll to do that. So this is on poll.lab.io, again open source. In fact, well, everything I do in my spare time ever has been open sourced. Did a whole talk about that. And yeah, this just updates as people vote on it. It's really handy for me to get a consensus of what people want to see, and then I can book them in, and it's really helpful. And I think a lot of products start off simple like this, and then they go and add features, which inherently brings along a lot of complexity. And something I love about kind of a few of these tools that I build is that it's really frictionless and doesn't require sign up. Because if anyone's going to cheat on a poll, they're just going to re-register lots of accounts. So just why make it, why put barriers in the way? People are going to find a way of cheating. And even the first page of this is enter the question. There's no landing page or nonsense like that. It's just really quick, easy, simple, and usable. Much like this is another little thing. It's basically Snapchat for text. You throw in a secret, you send the link to somebody, and by the time that the page is rendered, when they view the link, it's already destroyed from the database. Now, I'm not suggesting you share state secrets with this, but it is a little bit better than emailing people and asking them to delete it after they've read it. If you need to send like a server password to somebody over kind of a secure channel, then it just gives you kind of like a GIST-like unguessable URL. But it's no PGP, so please don't trust me that much. I'm not even encrypting it. The things I've seen. You actually have no idea. No. Yeah, no, there are some ISIS things in there, I know that. Moving on. And for me, open sourcing my tools is really important. It's not only a great way for me to give back to the community, but I get so much back from it as well in terms of people submitting bug fixes. But most importantly, open source gives me the freedom of time, the freedom to work on things that I'd rather be doing, new things. I feel less pressure to maintain these tools because they're open source. And if some developer informs me that something's broken, then often it will be fixed before I even notice the notification on it. And if somebody wants like Poll to scale to 100,000 users in an hour, then I'm quite happy for them to fork it and make it better and faster and even premium. I mean, what's wrong with there being a better tool on the market? I quite like that. And finally, I want to end on licensing. I think I'm ending a bit early, aren't I? How long have I got left? I don't know. I want to end on licensing. So if you do decide to share your code, I ask you to please license it. If you publish your code without a license, it is essentially copyrighted. And I asked Andrew Nesbitt, who did a libraries talk earlier today, how many open source projects on GitHub have no license, and he estimated it would be around 30%. There are going to be a few false positives in there, but it's just so simple to add a license and it allows people to use it. A great resource for this is a site called choosealicense.com, and it's maintained by the GitHub team, so they know what they're doing. But I tend to put everything out on MIT license. It basically means use it as you want, but don't sue me. Which is fine with me. This has been Don't Repeat Yourself, and I've been Adam. Thank you very much. Have we got any questions? I'm not sure how much time we got.
About 15.
Oh, really? Okay, I'm really early. I spoke faster this time.
I guess not so much a question, more a statement. We in my team, we actually just had a discussion yesterday about documentation. We also are using Ruby and Rails. The devs in my team came to the consensus that actuals using something like RDoc or Yard, they didn't feel necessary because that would actually be the last place they go to look for the documentation. They would certainly want something around context or why we've done a certain thing. So they may go looking on the wiki pages on GitHub or in the replay table. But next off, they go looking ideally in the unit tests. They felt the aspect tests are a fantastic way of documenting what your code is actually doing. And next, they would go to actually just read the code on the basis that, again, that you are following the convention, so you're not writing horrendous code. If we're writing horrendous code, then yes, we need to start documenting. But as long as we're sticking to the conventions of the community, they weren't too sure whether there was value in doing that. I guess just sort of your.
I'd agree with you actually around most notably around Ruby projects. There is a reason why in Ruby it's not called tests; it's called specs. There is a change in mindset that means specs should be written in a certain way that actually specify what your application is going to do instead of testing it after the fact. And certainly for Ruby applications, specs make excellent documentation, I think. I don't think necessarily in all other languages, though. It's not quite as expressive.
No, I mean, the reason I raised the question because I come off from a C# background where the sort of the preamble before every method would be sort of almost the default. And I found that when we moved over to Rails and Ruby, it's much less likely to happen, so hence raised the question.
I quite like having Yard though in our code because I don't actually often look at the exported documentation. It's there when I need to go in to give a big picture, how are these things linked, and maybe traverse through things through that way. But no, I tend to use just the comments inside the editor. Super useful for that, having really structured, well-informed documentation straight there. I do have one quick other tool that I can show you, which I built since we're a bit early. It's on a Heroku instance that would have spun down, so it might just take a second to load up. I find myself testing my assumptions through Google search all the time. Not actually searching for things, but making sure I'm using the right tools, seeing what's out there, seeing what I don't yet know about. So if I write in Google search here, hopefully it'll work in this box as well. Okay, no, it'll just jump straight up there. Brilliant, thank you. No, go over there. Oh, I can't see it. Look, let me just turn mirroring off. Okay, brilliant. There we go. So if I type GitHub versus, and I find myself doing this all the time. So if I'm going to use a devise or all sorts of packages, I just type the thing that I know about versus, and I get loads of suggestions back. And I can go off and I can go check those out. It's a great way of testing assumptions before you actually go and commit and build stuff in. So I built a little tool for that to allow me to do that a bit quicker. So here you type something. This is using a completely unsupported API, by the way. You just type Apple versus, oh no, not versus, it appends the verses for you automatically. And you get all the bits up like this, and you can just hit Microsoft and versus Sony, and Sony versus Samsung, Apple, and kind of traverse through things very quickly, and I find this really useful. I use it all the time.
What's the URL?
vs.lab.io. Yeah. Again, open source. Go make it better. Was there any other questions? No? Cool. I guess that's it. Go have some cake. Cake's really good. All right. Cheers.